Put it right there. It's the 20th. And we have arrived at our destination, which is this. Where we are right now is we are powerful mathematicians. We can solve by factoring when it's appropriate. We can solve special kinds of factoring, like differences of squares, pulling out a GCF. We can factor when appropriate by completing the square. We can factor, as we learned yesterday, certain types of quadratics by um, dividing both sides, getting x squared equals, taking square roots. And then we get to problems that don't really fall into any of the other categories. And that's where the quadratic formula shines. So I always fear that if I teach the quadratic formula first, that it becomes our go-to. And we as learners sometimes, occasionally, put the other methods on the back burner and say, well, why would I ever use anything other than the quadratic formula? And that's just not what I want to coach into you. I don't want to coach into you that kind of lazy thinking that, if this always works, why wouldn't I use it? And the thing is, just because it works doesn't mean it's the most efficient way to do it. So we don't want to be lazy and unintelligent mathematicians. We want to be good problem solvers and think about how am I going to get from point A to point B efficiently. So again, this does work 100% of the time. There is not a single quadratic ever in any universe where the language of math is spoken that the quadratic formula will not solve. Just FYI. Okay. So I got a few examples for you here. Let us get cooking. And I don't think still that this class is the appropriate place to do this. But if anyone is interested, I can show you how to actually derive the quadratic formula. It's not, as with all mathematics, it's not just some crazy weird thing that some bearded guy in a cave 1800 years ago just said, I will invent this. Like it's not like that. It happens naturally if you apply completing the square to a very general quadratic, which today is nowhere near the day for that. This lesson would go downhill quickly. But it's not that bad. And if at any point you're interested, let me know and I'll show you. But in the meantime, the quadratic formula says that when you are faced with a quadratic formula like any quadratic formula, that all x's can be found by doing the following. You take the opposite of b, you add or subtract the square root of b squared minus 4 times a times c, and you divide it all by 2a. All right. And you know this because almost all of you had me for Algebra 1. So back in Algebra 1, I gave you the opportunity to earn some extra credit by singing the quadratic formula song in front of everybody. So I know you guys all know the little ditty. It's sung to the tune of like the Pop Goes the Weasel song, right? Right? You remember that one, Coulter? The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Is that ringing any bells? You just saying that to be nice? Yeah, fair enough. Yeah. Thank you for your candor or honesty, whatever the word is there. Good. So if you're interested in that, I'm not going to offer extra credit. That ship has sailed, but it does help. It does help to get the formula stuck in your head. Whether it's in your head via song or whatever, this should be right at your fingertips for the next couple of days. You should not ever be in a place where you go, well, what is it again? It's already in your notes right now. And when you get today's assignment, it's going to be written at the top of that. Like it should just be plastered all over the place until you no longer need it as a reference. Okay. But that is it. And like I said, it works 100% of the time. So in order to use the quadratic formula, you need to be able to find values for A, B, and C. And those come from setting the quadratic expression on one side equal to 0. So at this point, we've got a little bit of tidying up to do. I will continue to say that you're going to have more success if you keep your x squared positive. The quadratic formula gives no craps though. I mean, like you can do anything you want provided that you have it set equal to zero. But I find generally that if we're more repetitive in our prep actions, that we're going to be more successful. So I will continue for our time together to make sure that A is positive. In other words, that the x squared term has a positive number in front of it, right? Left side, right side is completely irrelevant. It doesn't matter. So what I'm going to do is I'm going to leave the 10x squared on the left-hand side. I'm going to leave the 10x on the left-hand side, and I'm going to bring the 1 across. Remember, it is not okay ever in any universe to bring something across an equal sign and not remember to change its sign. And if you don't want to remember that, then you can go mega old school and do it like we did years ago and just show yourself subtracting 1 on both sides so that you don't forget, okay? So there we are. We're all set up and good to go. What is A? He's right there. A is the number that comes off of x squared. It's what we call the leading coefficient. So A is 10. A, B, and C will never contain variable values in this class, not in this school. There will come a day, maybe in some upper level college-y kind of class, where maybe we start kind of abstracting it and finding variable values in the quadratic. But for now, that's completely not going to happen. So A is just a number, 10. What's B? Also 10. Just happens, coincidence, that the number in front of x is the same as the number in front of x squared. Okay, so B is positive 10. I would strongly encourage you to write these down. Even if you don't write A, B, and C, write them in order. Pull them out of the equation and separate them so you can see them. And what is C? It is. At this point, everything we need to have done is done. We have our A, B, and C values laid out. We have our quadratic formula just lurking off to the side. And it's time to just plug everything in and figure out what the values of x are. This is not a factorable quadratic. It is not appropriate to try completing the square. I mean, you could. It's just going to be a little tricky because of the fractions you're going to get. It's certainly not a difference of squares. It doesn't fit the mold for yesterday. So again, I personally feel like the quadratic formula should be our backup plan. When all those other methods don't work, the quicker ones, then we defer to this, the longer method. I find this to be a tad annoying, kind of a pain, but it works. That's what's good about it. So let's get to it. So we're going to now state that the x's that solve this equation will equal what we're about to do. The first thing up here, I'm going to point to it with an arrow, says negative b. When you hear like the little song or whatever, people often say negative b. I would encourage you to think of it as the opposite of b. Okay, so that you don't say something stupid in your head like, is that always going to be a negative? Of course it's not, right? If b is already a negative, then the negative of a negative or the opposite of a negative is a positive. In this case, b is 10, so the first thing we're going to write is the opposite of 10, which is negative 10. And then we're going to put plus or minus, and we're going to draw always a square root sign that is longer than you think it's probably going to need to be. Okay, because we've got some writing to do in there. It is never okay for your square root to not encompass everything inside of it. So make sure that square root is plenty long, or you'll have to add to it. No big deal. All right, what's the first thing we do inside the square root? B squared. And if you know b being 10, 10 squared is a simple 100. I would never write b squared there. I would just do it. If it's negative 4, write 16. If it's 5, write 25. If it's negative 9, write positive 81. Is that number always going to be a positive?
Yeah.
Yeah, it is. Why?
It's
Yeah, because no matter what you're squaring, it's going to come out to a positive. I don't even care what b is. When you square it up, if it's a negative, it's getting washed away. If it's a positive, it obviously stays positive. So that number, despite what your calculator will tell you, I'm going to pause here and make sure you hear me. That number will always be positive. If I had $1 for every time some knucklehead typed in like negative 14 squared and then had the nerve to put negative 196 there, could probably buy a car. Don't do that, okay? Bear in mind that it will always come out positive. So if you insist on using a calculator, which we will from time to time, these numbers can get a bit big, just don't put the negative in or put it in parentheses. Okay. So b squared will always be a positive. And then the rest of this, the way I personally like to do the quadratic formula is to just build some template shells. So I'm just going to write minus 4. And instead of actually putting numbers in here, I'm just going to put blank and blank. I don't know what it is about this. I figured out years ago that if I just pause here and don't put anything in, then I will allow my brain a little vacation, about a 1 or 2 second vacation, so I don't put the wrong numbers in there. And then I'm going to go to the bottom and I'm going to just do this math as I go. So I'm going to do 2a, which of course means 2 times a. And since a is 10, what am I going to write there? 20. I like to now go back that couple seconds of me going down and working on the little simple third grade math on the bottom gives me a little bit of a break to now go up and make sure I put the numbers A and C in those blanks and not accidentally something else. So what's going in the first blank? 10. What's going in the second blank? -1. Make sure you know where everybody goes. Everyone has a place, right? And if you keep that purple formula just sitting around, you're never going to wonder what goes where. All right, keep it handy. All right, now comes the work. I haven't done anything yet, really, just a lot of flapping my gums and talking. But at this point now, I do have to do some mathematics. What do you know from our first time through the quadratic formula? What do you know about what's going on in this yellow thing? Anything? The sign before the 4 will switch. Very good, Parker. I'm going to point to it with a green arrow. It's this one right here. I would say about 50% of the time, that sign will have to change. And the reason it changes is because it's eventually going to encounter a negative maybe along the way. It's not going to be in the A spot unless you're one of those weirdos that makes A negative. If it's going to happen, it's going to be your C value. And if C is a negative, I'll point to him with another green arrow. That minus and that negative crash course, flood towards each other, and they create a plus, not a positive, but a plus. So what's really happening inside of the square root here is not what you think it is. It's going to become 100 plus 40. Don't overcomplicate this. Don't, make yourself ask questions about should I distribute? Well, you don't distribute. No, you just multiply. There are 3 numbers in this purple box. And as far as I'm concerned, their names are 4, 10, and 1. I've already tackled the fact that the sign's going to change. I'm not going to burden myself with negatives. I'm just going to do the math. And whatever I get, I'm going to put after either a plus or a minus sign. So the quadratic formula cleans up quickly and nicely. We now know that x will be equal to the opposite -10 plus or minus the square root of 140 over 20. And I do have an assignment. I decided not to give it to you today. I'm going to keep it queued up probably for tomorrow. But what it is just an assignment of this, the endings. I actually called it quadratic formula endings because this is where the mistakes and the questions usually happen. I can get most kids to this point, but it becomes here that you're going to remember little things like the Dorito that I've talked about before, or those of you that continue, which just reminded me I owe you guys something. If you continue to struggle with the square root of 140 or the square root of 32 or the square root of 288, it's going to just keep nipping at your ankles until you face it, deal with it, right? How do you break down a square root of 140? Because it's not okay. You've seen this one before. Not that you would memorize all of them, but it's out there. This would be a good time to have that piece of paper out with all the square roots on it and then flip it over. And I've told you this before. Every time we get one, like, do you think you're ever going to see the number 140 again? I bet you are. And if you just add it onto that paper, I would just, every time I get one, I would add it and just build myself a page of resources, my page of square root deliciousness in a bit, in a bit. They're over there. So I'm going to break it down into the square root of 4 and the square root of 35. And the reason I'm going to do that is There's three reasons. Number one, because it equals 140. Number two, because 4 is on the red list. And number three, because 35 is dead. So that's why I know now that this has to be the best way to do this. And so I'm going to write this as 2 roots of 35. So at this point, what I do is I go back to my answers, and I swap out the root of 140 with 2 roots of 35. And I'm going to say x equals -10 plus or minus 2 roots of 35 over 20. And again, all of you except maybe the one person in this room, two people that didn't have me for Algebra 1 would remember it's at this point that I draw this guacamole flavored Dorito. And this is not something that I just draw because it's fun and cute. It's just, it helps kids, I think, to identify the next step. And the next step is to look for things in that Dorito that can all be divided, be reduced. This isn't something, depending on your teacher, you'll have teachers in college who may want you to divide it out diagonally individually. Most of us don't. And so what I look for is, can I make progress, but do all three numbers in the Dorito agree to the progress? What can they all be divided by? Which leads us then to what will be our final answer, which is to say then that x is equal to half of -10, so -5, plus or minus 1, if you want to write it, I'm not going to, times the square root of 35 all over 10. And that is a completed problem. How many answers do you see in the box? There are 2. And I'm not going to write this every time. The computer will write your answers like this, by the way, but I don't. Most people are fine if you leave it like this, but we also would be better if we know for a fact that you can show us that there are 2 answers. One of them is x equals -5 plus the square root of 35 divided by 10, bless you. And the other answer is x equals -5 minus the square root of 35 over 10. There's a name for those. They're called irrational numbers. We've talked about this. And the reason we leave them like that is because they're irrational. Now, if this were a word problem, an application problem, and you needed like an approximate value for x, we can do this. Let me ask you a simple math question. What's the square root of 35 pretty close to? If someone just said, quick, pick a whole number that it's really close to, what would you say? It's about 6. Now, you got to know the square root of 35 is just a hair off of the square root of 36, and he equals 6. So in your mind, if you just put 6 there, you can actually see that these are real numbers, right? What's -5 plus 6? 1. So one of the answers is approximately 1/10. So 0.1. And the other answer, if I put 6 in place of my ugly root, what's -5 minus 6? -11. So my other answer is approximately -1.1. So I don't want you to think that those are like weird things. Like yes, they're irrational and they can be a bit scary, but they're actual numbers. They're just not perfect, right? Yeah. So that's how you attack the quadratic formula. Let's go again, round 2. So this time we're going to have 6x squared equals -2x plus 6. What is step 1? I would accept 2 answers on this. Yeah, that's one of the answers I would have hoped you'd say, right? Based on where we are in today's lesson, I would 100% expect you to say what Jesse said. Let's leave the 6x squared. Let's bring the 2x over as a plus 2x, and let's bring the 6 over as a minus 6. And now we're right where we want to be. I'm just going to throw this out and see if anyone spots it. What else could we do? You can. And I'm going to say this, and some of you are going to not hear it because you're probably already tuned out and daydreaming, but here it goes. If an opportunity presents itself to divide early, you should take it, right? Because zero's flexible. 0 doesn't care. 0's like, divide me by whatever you want, bring it. But then I look at the A, B, and C values, and I'm like, hold on, I could make my life a little bit easier if I divided all you idiots by 2. So for the sake of this, I'm going to do that. You should look for that. It'll really help you sometimes. And so if I divide everything in this equation by 2, totally legal, I wind up with 3x squared plus 1x. I'm just going to write x minus 3 is 0. And it's at this point that I would now dive in. Okay, there's no more initial progress to be made. So what's A? B, C, and we're ready. So here we go. We're going to say that the x values that solve this equation are equal to what? What goes first? -1. The opposite of B is -1. And then I'm always going to put my plus or minus. It is a verb, plus or minus, because there's something in front of it. It's not a positive negative sign. Plus or minus, and what goes initially right away inside the square root. You should be looking at your formula right now and b squared, which in this case is 1 squared, which is 1. Okay, 1 squared is 1. And at this point, I'm always going to do it the same way. If you watched me teach this lesson 10 years ago, if you watch me teach it 5 years from now, you're like, wow, he was doing it then. And future, wow, he's still doing it in the future. I'm always just going to put -4 and then build a couple of empty spaces that I'll fill in about 20 seconds. On the bottom, I am going to multiply 2 by A. What's 2 times A? 6. And now I'm going to go and I'm going to backfill those because in them I want to put the right guys. Who goes in there in order? Who are they? 3 and -3, A and C values. Is the sign going to be a switcher or a keeper? It's another switcher. And again, you're going to find that very frequently to be the case. Okay. I would say half the time. I mean, I don't know if that's accurate, but I feel like it probably is, right? C is going to be positive or negative. But if he's negative again, though the minus sign that where I'm moving the little cursor and the negative over here, they're going to find each other. So just get it done. So what's really happening inside the square root is not what you see. And it's not as complicated as what you see. It is 1 plus 36. And 36 is a simple calculation that I get from just doing the numbers in the white box. 4 times 3 is 12. 12 times 3 is 36. Again, we're not talking negatives because we already slayed that dragon. What is 1 plus 36? So we have x equals -1 plus or minus the square root of 37 over 6. What do we do now? 37 is a dead root, so what do we do now? We're done. Put it in a box, call it a day. The guacamole colored flavored Dorito doesn't even exist in a problem like this. The guacamole Dorito will not even have any relevance until you place a number right there. If you don't place a number right there, then there can't be an opportunity for that three-headed division. Done. These become our favorites because as you'll see, like the last problem and a problem yet to come, sometimes there's a lot of work yet to do. But when the root's dead, you're like, boom, thank you. And you box it up and you're on to the next one. So those are our solutions for that one. Okay, next one. We have 4x squared plus 11x plus 17 equals 11. Give you a second to copy that down, and then I'll start asking you questions. Everybody ready? What do we do first? Move that 11. Good. So we're going to be left with 4x squareds plus 11x's. If you subtract 11, you get 6. Don't say something blasphemous like 28. See anything we could do? Good. I don't either. That 11's like, aha, suckers, you can't divide me. So he's a deal breaker. So we just hop right in and ready, set, go. A is 4, B is 11, C is 6. And we dive in. It's what you do. Find your ABC and hop in and go for a ride. So X equals what? Plus or minus the square root of what? 121. Good, because that's what 11 squared is. And then I'm going to put -4. And then I'm going to draw a couple of blanks and I'll tell them, hold tight, little homies. I'll be back in a sec. And then I'm going to jump to the bottom. And on the bottom, I'm always just going to do double A. What's double A in this case? 8, 2 times 4. And now I reset, go back up, take a sip of coffee. What goes in the blanks?
4 and 6.
That minus sign in the discriminant, I haven't used that word yet. The stuff inside the square root is called the discriminant. FYI, won't talk too much about that right now. But the minus sign inside the discriminant, is he a keeper or a switcher? He stays. He has no reason to switch. He's not going to encounter any negatives. So at this point, what I see inside of the square root sign is not that. I see, my brain sees 121 minus 96. Okay. And again, that 96 is the result of multiplying those numbers in the box. It's just old school, grade school multiplication. 4 times 4 is 16 times 6 is 96. Now I got to do a little bit of math. What is 121 minus 96? It is. So I wanted this to be our third example because this, like you've seen before, is a pathway problem. We saw it with completing the square, that sometimes in math, there's work I can actually do that it doesn't involve breaking down a square root. It doesn't involve making a tree. It doesn't involve a Dorito. It just is, it's simple math if I allow myself to see it. The key, though, to seeing it is, what is the square root of 25? It is. And so the moment that the roots vanish, we have left the land of irrational and we have now entered the realm of rational. And what I'm asking of you now is something that is not appropriate for an 11th grade math class. This is like a 7th grade math question coming up. There are two answers, and it is incumbent on you to figure out what they actually are. We are not going to leave our answers as negative 11 plus or minus 5 over 8. We're going to track the pathways and attack them one at a time. The first pathway is the high road. What is negative 11 plus 5? Negative 6, and then I'm going to place it over 8, and then I'm going to reduce it, because that's what we always do. We've been doing it for years. What is the answer then to that one? So our answer, first off, is negative 3/4. That is one of the solutions to this equation. The other pathway is the low road down below, the yellow one. Just math them one at a time. What's negative 11 minus 5? Negative 16, which when you divide it by 8 is equal to. Therefore, those are your solutions. The connection to be made here, and we had this talk, but when we did completing the square, is what that box means is that the initial problem could have been factored. That's what rational solutions will always imply. Going back to the beginning of the problem, had we later on, when we had the freedom to do it however we want, had we just, if someone green lighted us and said, just solve it, I could have factored if I was thinking in those terms. But that's what it means. Rational solutions equal factorability. Okay. So now you've seen all three flavors. You've seen one with a root that we could break down. You've seen one with a dead root, and you've seen one that creates rational solutions. So now that we've kind of seen them all, let's knock out a couple more and see where we're at. 12x squared equals 15 plus 12x. Step one. Yeah, get those idiots over to where they belong. And remember, don't be a rookie. Don't forget to change signs. Never forget to change signs. Bless you. What comes after the 12x squared? Minus a 12x, because he changed, and after him, minus 15. And now we're ready. What do we do? Yeah, and if you miss that, you're going to hate this problem way more than the person sitting next to you who spotted it. So come test day on this, you don't see these opportunities, you're going to be dealing with big numbers, and that's on you. Dividing numbers by 3 makes them a lot easier to work with. So if I divide this whole equation by 3, I knock everything down. This guy becomes a 4, this guy becomes a minus 4, and this guy becomes a minus 5. And 100 out of 100 people surveyed said, yeah, I'll take the smaller ones, please. What's A? B? C? That was a nice conversation I just had with myself. Good. So A, B, and C, we're ready to rock and roll, and let's begin. We're going to say that our x's that are needed to solve the equation will equal what? What goes first? Positive 4, because it's the opposite of a B. And B is already negative, and the opposite of a negative is a positive. And then we're going to put plus or minus, draw an awkwardly long square root sign, and let's get rocking. What goes first inside the square root? Stay with me, Coulter. 16. B squared is negative 4 squared. It's going to become a positive, and then I'm going to put minus 4 blank blank all over double A. What's double A? I'm going to go backfill the blanks. What's going in the blanks?
4.
Nice. Is the sign with the little yellow arrow pointing at it a keeper or a switcher? It's a switcher. That's it. Enough said. No more talk about negatives. Once you know it's a switcher, don't burden yourself. Like if you're going to use a calculator for 4 times 4 times 5, don't type it in with any negatives. It's going to make you do dumb things. You've already accomplished understanding that it's a plus. So don't go there anymore. So what's inside the square root has nothing to do with negatives anymore. It is simply 16 plus 80. End of story. The minus and the negative destroyed themselves in the act of creating a plus. What is 16 plus 80? So we now look at a much cleaner version of the answers. X equals 4 plus or minus the square root of 96 all over 8. Is 96 dead? No, it is not at all. There's a lot of meat on that bone. Ah, boy, there you go. 16 times 6. That's another one you can just add to that piece of paper. Every time you see one, add it. You can fit like 30 of these on the back, 40 of them on the back of that piece of paper. Every time you see one, just add it. It's like your own little database. So this is going to become 4 root 6. Now I'm going to go back up to where it used to say the square root of 96, and I'm going to be like, yeah, I don't think so. You're going to be 4 plus or minus 4 roots of 6 all over 8. And the Dorito is now in play. Obviously, I don't care if you draw the Dorito. I just say stupid things and draw stupid things to try to help people learn. But there's a three-headed division problem here. What can all the numbers in the Dorito be divided by? 4. So I want to divide them all by 4. And the reason I like this problem is because it gives me an opportunity to remind you that some ones are more important than other. When I divide these, this becomes a 1, this becomes a 1, this becomes a 2. One of those ones can go, sail away. One of them has to stay. Which one is important? The first one is a placeholder. You get rid of that guy and you're like, oh, come on, man. Someone's got to hold the fort before the plus or minus sign. And so he cannot vanish. He has to stay. So we need to state that x is equal to 1 plus or minus the square root of 6 over 2. A 1 in either of the other two spots can go away. The one out holding the place, he can never go away. Good. Let's make this official and do one more. We're obviously not going to have a lot of work time today, but that you know always what that means is on the other end of that tomorrow, I'll give you a nice big chunk of time to work on your worksheet. Okay. So let's tackle one more, make it official. So we have 5. By the way, I'm not moving x squared around. Eventually, I'll make it a little more exciting and start throwing him different places. But for now, ho-hum, he's just on the left, right? But that doesn't matter as long as he's positive. But uh, when I wrote these, I was like, let's not worry about too much prep work here. No stress. All right, don't shoot yourself in the foot. Make sure all this initial stuff goes well. You'd hate to be trying to solve the wrong equation because you did something goofy. What happens first? Yep. So the 3x is coming over as a subtraction 3x. The 5 is coming over as a plus 5. The 5x squared is like whatever. You guys do what you need to do. How many x's will we have? Yeah. And what will our constant, our c value be? Good. You see anything we can do to simplify? I don't either. The 6 and the 10 play nice. The 5 and the 10 play nice, but together they're not a very good team. What's A? B? C? And we're off. 6th verse, 5th verse, same as the first. Just plug these guys right into our happy little reliable formula, and here we go. X equals what? Positive 6 plus or minus a big long square root sign. What goes first in there? Positive 36 minus 4 blank blank all over what? Yeah, boy. What's going in those blanks?
Negative.
Is the sign a keeper or a switcher? It's a switcher. So at this point, all negatives should be omitted from consideration. And we just do math, little kitty math. What's inside the square root is 36 plus 200. Plain and simple. 4 times 5 is 20. 20 times 10 is 200. What is 36 plus 200? So x is currently equal to 6 plus or minus the square root of 236, all divided by 10. You think 236 is dead? I don't. Here's what I know. Anything that ends in a number that's divisible by 4 can be divided by 4. So in my head, I think about, did you catch what I just said? You see how it ends in a 36? Okay. Anything that ends in 36. If you had a big long number that ended in like 2, 4, you're like, oh, I know I can divide it by 4. That's a test for 4. It's a nice test to have in your back pocket. So worst case scenario, like in your head, if you took 236 and you broke it up into 236, right? And you divide them both by 4, mental math. What's 200 divided by 4? What's 36 divided by 4?
Wait,
9.
no.
So what this means is that I could take the root of 236 and I could break it down into 4 and 50 plus 9, right? A little bit of mental math there. You don't need no stinking calculators. We haven't used one yet today, which is nice. I haven't. Have you? Maybe you have. I don't know. Is 59 dead? Dead or doornail, right? So I know that 4 and 59 are money. So I can now say, okay, so here's where I'm at in the process. X is equal to 6 plus or minus 2 roots of 59 all over 10. Does the Dorito play? Yeah, there's a 2, right? As long as someone comes out of that root, the Dorito's in play. It doesn't necessarily mean that there's going to be simultaneous reduction, but it means that there's a possibility. What can all the numbers in the Dorito be divided by? 2, which results in a 3, an unnecessary 1, and a 5. That 1 can go. Ones where either of these green arrows are pointing can go when they appear, right? The first one is sacred, though. So final answer before we call it concluded. What does x equal?
3 plus or minus square root of 59 over 5.
Bam. Okay. Here's what I'm going to do. I'm going to hand out assignment number 27. I don't expect you to get much or any of it done right now because I've worked you right up to the bell, but I'm just going to get it out there and then you'll have it in your possession and you'll bring it back tomorrow. I could just hand it out tomorrow, but I'm not going to. I'm going to give it to you now since you're here. And then tomorrow I'll give you a nice big chunky work day. Sound like a deal?
No.